Scene 1. Introduction. Nuclear physics is the study of the smallest but most powerful part of matter, the atomic nucleus. Imagine the atom as a miniature solar system. Electrons orbit like planets, while at the center lies the nucleus, packed with protons and neutrons. This tiny core holds forces and reactions that store unimaginable amounts of energy. This energy can light up cities, power spacecraft, or cause massive destruction if misused. Scene 2. The nucleus. The nucleus contains protons, which have a positive charge, and neutrons, which have no charge. Both protons and neutrons are made of even smaller particles called quarks. Nuclear physics seeks to answer important questions. How do these particles stick together despite the repelling force between positive protons? Why are some nuclei stable for billions of years while others decay in seconds? How can we safely use the energy from these processes? Scene 3. The strong nuclear force. Protons naturally repel each other because like charges push apart. But inside the nucleus, a powerful force called the strong nuclear force overcomes this repulsion. This is one of the 4 fundamental forces of nature, along with gravity, electromagnetism, and the weak nuclear force. The strong nuclear force works only at extremely short distances, less than a trillionth of a meter. Without it, the nucleus would fly apart instantly. This force is why atoms and all matter exist. Scene 4. Fission and fusion. There are 2 main ways to release nuclear energy. Fission splits a heavy nucleus, like uranium-235, into smaller nuclei, releasing huge amounts of energy. Fusion joins light nuclei, like hydrogen, to make a heavier nucleus, like helium. Fusion powers the sun and hydrogen bombs. On Earth, scientists are working to achieve fusion as a clean, nearly limitless source of energy. Scene 5. Real-life applications. Nuclear physics has many uses beyond weapons and power plants. In medicine, it powers radiation therapy for cancer and medical imaging, like PET scans. In industry, it helps detect leaks and study materials. In space exploration, it powers deep space probes like Voyager. In research, nuclear reactors and particle accelerators reveal the universe's secrets. Scene 6. Safety and the future. Nuclear energy must be handled with extreme care. Accidents like Chernobyl and Fukushima show the risks of radiation release. Safe handling requires shielding, strict regulations, and secure waste storage. Scientists are developing safer fusion reactors and small modular reactors that produce less waste. The goal is to use nuclear power for clean, reliable energy without harming people or the planet. Scene 7. Conclusion. Nuclear physics reveals that even in the tiniest spaces, the universe holds unimaginable energy. Our challenge is not just to understand it, but to use it wisely for progress, safety, and the future of humanity.